Bad data is often somewhat of a scapegoat when it comes to the failure of multiple supply chain projects. However, when looked at more detail, this vague term can be used to hide a whole multitude of sins. Today on LokadTV, we're going to understand why this is such an imprecise diagnostic and also understand what are some of the data challenges which can be encountered by both software vendors and supply chain practitioners alike. So Johannes, why is bad data such an easy excuse?
I mean, first, because data can't complain. The data suddenly is not going to defend itself to say, well, it's not my fault. So you see, it's just a concept. So you're blaming something inert, which is better than blaming, a colleague that is going to take it personal and is going to fight back against that. So, halfway joking, it's a convenient way to frequently, put the blame on something and leave it at that. But the reality is that when you go to the root cause, down the road, it's always, people, and there is so who is actually responsible for the problem, and blaming the data is kind of skipping the step of saying, well, we are not going to really, identify what is the root cause of the problem.
It's definitely easier to sort of have a go at something that's not going to fight back. So how can we be a bit more precise then? How can we sort of say what some of the challenges are?
So indeed, I would say data-related problems are probably the number one, cause for failure for supply chain optimization projects. But here there is some misconceptions. The first one is that when people say bad data, they mean like as if data was corrupt or like having like incorrect numbers. And I believe for most, let's say, Western companies, they have had very accurate data for literally decades now. So almost nobody is like entering part numbers with a keyboard, doing mistakes, typos every 5 part numbers. I mean, they use barcode scanners and all sorts of tricks when it's not even RFIDs. So the amount of, I would say, bad data, truly bad data, like bad data entries where you have something that is completely garbage. It does exist, but usually it's like a very thin fraction of the data, and it's not it's not sufficient at all to explain why most of the initiatives that fails because of data-related problems do fail.
Okay, so if the vast majority of Western companies are actually collecting pretty good data, what are some of the challenges that we can encounter which actually make us think that data is not so good?
So first problem is to get access to the data. So here and you would be surprised. Again, companies have been running with various flavors of ERPs or WMS or TMS or whatever you have, MRPs, whatever enterprise software you use to basically run and operate your company on a daily basis for decades. But most of those systems are not exactly super, I would say, company friendly when it comes to export the data out of the system. The very old systems, when I say very old, like now 40 years old systems, sometimes you end up with very bad setups where you have systems that are so ancient that you don't even have like a proper relational SQL database backing the system. Then in this sort of situation, it's really hell to extract the data because the backend is something that is typically completely obsolete and proprietary and not accessible. So that's a hellish scenario. That can happen, but again, this is pretty rare. So you want to get access to the data, and sometimes it's a problem. So who is in charge of doing that? Well, you have like multiple responsibilities here. First, you can have just the software vendor who did not provide any meaningful documentation about the system. So I would say worst case scenarios, you open your DB2 database and you just realize that your ERP contains 2,000 tables and each table having from 20 to 200 fields, and that's a nightmare because you have like literally I mean, it's completely huge, and you don't even know where to look for. You can have a problem with the vendor. Then you can have a problem with the integrator. The problem with the integrator is that you might have conflict of interest. I mean, some integrators might have like a vivid interest in selling you their own recipe for supply chain optimization, or for this module or this other module or something. And when you ask them to basically do a data extraction for you, your internal teams, or whatever initiative you want to carry with another vendor, the integrator can have, it does happen, we've seen that many times, is just plainly uncooperative. Because again, for them, it's just in their strategic interest to be non-cooperative. And here you have like an hostage situation where the company is matter of fact, taken hostage by the integrator, the company, the IT company responsible for configuring, sometimes hosting, and overall, maintaining the ERP or the other computer system of the company. So that's another type of data problem, but you see, it has very little to do with the data.
Yeah, so definitely like not being able to access your data sounds like a fairly huge blocker. How about some of the other sort of challenges that can kind of occur? A big sort of headache that a lot of our clients kind of have is when they migrate from one ERP system to another ERP system. So what can that do to the data? Why can that kind of cause problems?
So that's a sort of situation where you can have another type of bad data, but here it's really the data that is bad, is when you have like garbage integration. So I say typically data entries are correct, but when you move from one ERP to another, what maybe the vendor, maybe the integrator, maybe your internal IT department, what they are going to try to do is basically to migrate the historical data from the old system to the new system. The problem is that you don't have like a one-to-one matching between what was like a sales receipt in the old system and what is a sales receipt in the new system. Maybe things are just organized differently, and so there is no clear way to basically re-import the data from the old system to the new system. And then you end up with maybe tentative integrations, and where it can lead to data corruption is that if you, I would say, do an improper reintegration of your history, it will not prevent your company from operating day to day. You see, if the historical data is like incorrectly imported into the new system, for most of the daily operations, it will not have any impact. And even if it has an impact, usually someone will just do like a quick fix of for something that is incorrect and proceed. So it might be a source of ongoing friction, but first it's I would say disappearing fast, because if people are stumbling, for example, let's say you have like supplier codes that are incorrectly, that have been incorrectly imported. I mean, chances are that you don't have like 1 million suppliers. So your most frequent, your top 100 most frequent suppliers are probably going to be fixed in terms of fixing the incorrect data entries within 2 weeks from the date where you start using the new system. And maybe, 3 months down the road, you have virtually fixed every single incorrect supplier entries. But the problem is the historical data. People are not going to go back and fix, the historical data. So let's say you had like 5 years worth of history, maybe 3 months down the road when you set up a new ERP, your ERP is now clean for day-to-day operations. I mean, you're back to 99%, data entry accuracies with this new system. But what was, in the far past, like 3 years back, that might be complete garbage. People don't care until you try to do like a supply chain optimization, quantitative optimization project, and then you start to, I would say, to do data crunching on the entire 5 years, and then all those problems re-emerge, and you just realize that it's a big pain.
And so let's talk about some of those sort of projects that you can do, and particularly the one that we're interested in is forecasting, and these forecasts are built on this historical data. If you're forecasting for something in the future, how easy is it, because that future is inherently uncertain, how easy is it to kind of spot these issues that might have occurred in the past?
It's easy to spot those issues when you have like visible problems, such as, for example, imagine you're looking at your sales history and you have some things, you know, that is gently seasonal, and then you have like some things that is like 0 for 3 months and it goes back to something reasonable. So if you look at the time series, you would say, okay, I have like 3 months of data where data is missing or something. It's a very visible data integration problem. But then, for example, you can have subtle changes. Subtle changes, for example, is what are you calling, you know, for example, sales. For example, if you have a product that is sold, and then you realize that let's say 3 weeks later, that actually the credit card was stolen. So this unit that was sold, actually you got a charge back on it. And so ultimately it was physically sold, but you never got paid because somebody actually stole from you. I mean, they used a stolen credit card, so they didn't really pay. And maybe in one system, you would count all sales, you know, including frauds, and some other system you would count all sales, but minus the fraud, because the frauds will be filtered out. I mean, when I say fraud, it can be other kind of problems. It can be returns, it can be defects, it can be other things. So what I mean is that when you have like a semantic that is evolving over time, especially when you change from one system to another, that can lead to lots of very subtle issues that trigger tons of problems and that are much harder to spot in the historical data because it's just not obvious. It's just that the very definition of the data you're looking at, actually this definition change over time. But unless this change manifests itself as with a big, you know, spike or bump into your historical data, that can be quite hard to spot actually.
Okay, and another kind of issue that's really common with the customers that we speak to is all to do with sort of scalability. And as a company kind of grows, they initially start off having quite good data, but as they grow, it starts to get messier and messier. So what are the kind of the issues that scalability can kind of introduce?
So let's talk about the situation where you don't have any scalability problems. So what do? You just copy, like every single day, all the data of the company. That may sound very brutal to say, oh, every single day I'm just going to export like 5 years worth of data. Well, maybe not. I mean, for many companies, especially I would say, any companies that is, let's say, below $50 million turnover or 50 million euro turnover, usually the entire 5 years history, if you take like everything in the company, is typically going to be less than 10 gigabytes. So, I mean, in these sort of things, you could think that, well, is it really worth even trying to optimize that? I mean, just think of it. It's a sort of, you take like the entire data of the company over 5 years, and it would fit easily on a smartphone. So obviously, you can try to micro-optimize the thing, but bottom line, mostly it doesn't matter. And then when you grow to larger companies, you just realize that suddenly you end up with maybe, you know, dozens of gigabytes, maybe hundreds, maybe terabytes or multiple. And then you realize that you need to go for like incremental data retrieval. So that means that you're going to retrieve your data piecewise. And every single day, you're going to extract a portion of the data in your system. Some very modern systems are, I would say, very accurately designed to be able to do this incremental work in ways that is both reliable, correct, and fast. But frequently, people realize that historical systems were not exactly designed to do these sort of things. So it's kind of a hack. The ERP, for example, is not designed to have like to offer to its client companies like a clean daily increment of everything that has changed from one day to another in the ERP system. So you need to do a lot of complicated things to basically build yourself this clean daily extraction. And then in the process, you have, I mean, you expose yourself to many to bugs and a lot of very mundane problems where you just get it wrong. And so in the end, you end up with bad data just because you want to do the data extraction in a way that is incremental, and you just do it wrong. And by the way, it's kind of tricky. Again, you have to think that you have a system that has not been necessarily been engineered at all to facilitate this sort of task. When you think about debugging, again, very mundane problem. I just want to copy data from this place to another place. And how much time will it take me to check whether my just data copy is actually working? Well, if the whole process takes like a minute, it means that somebody in your IT department can just take 5 minutes, trigger the thing, make sure that it works, and basically in 5 minutes they can be confident that it's just very simple data copy is actually working. Now let's imagine that you have the system where you are ending up with a process that takes like say 6 hours to complete. Then suddenly imagine what is going to happen in your IT department. Somebody is going to start the process, realize first they are going to wait for 10 minutes, say, okay, this thing is taking so long, I'm going to do something else. And then they might even forget that the thing is running. And then the next day, they might actually notice that there was like a small bug and it did crash. So actually, and it only crashed after like 6 hours. So it's a very tedious way to reproduce a poem, because to reproduce a poem, it will take 6 hours of delay. And most likely, they're going to launch a calculation, forget about it. And so bottom line, you end up with problems that where you should be able to fix that in just a few hours. And suddenly, because there is more data involved and processing time are longer, it turns into a very tedious process where the total delays become weeks. Not because it's weeks of effort, it's because people launch the thing, forget about it, and just come back the next day. But then, in terms of rapid iteration, suddenly you're like iterating with one iteration per day, and it's very, very slow.
So how sort of widespread would you say these problems are? There are a lot of companies out there that actually believe they've got very good data, but actually in reality, when you look at it under the surface, it's actually a little bit corrupted.
Yes, and there is another problem that we have barely discussed is the semantic itself, just the plain semantic of this app. And again, many companies who believe they have good data actually don't. But it's not that the data is bad, it's just that the data has unknown semantics. So what do I mean by that? I mean, if we say order date, something that is as basic as an order date, are we talking of the order date from the client? It's a client order or purchase order? So first, we don't know. Are we talking of the time the order was placed by the client on the website? Was it the time when the order was registered in the system? Was it the time where the client started to open a new basket on the website? Is it the time where payment was confirmed as valid by whatever payment systems that you have? Is it something that is the last time this line in the ERP was touched for whatever reason? So maybe this order date has been updated later on because there are other processes running in the ERPs that can update this date afterward. I mean, there is like 20 different potential interpretation, at least, for what this order date means. And when we start, working with clients, typically we end up with tables and columns. And if we have at least one line of documentation, we consider ourselves lucky. And the reality is when we are done, preparing the data, we have nearly 1 page of documentation per field per table. So I mean, a typical supply chain situation is like 20 tables with 20 fields. So we are talking of literally 400 fields, so that's 400 pages worth of documentation, just to clarify what the data mean. And people are just usually very, very surprised, say, well, that's nearly insane, 400 pages of documentation. And they'll say, well, it's not insane, it's just the complexity of your supply chain that is just reflected in this data. And if you don't do this work, what you invariably end up with is data that you don't understand properly, and thus, guess what? Garbage in, garbage out. But it's not that the data is garbage in the sense that it's like the numbers are wrong, it's just that you don't know what the date means. So most likely, if you have like a date that you don't properly understand, whatever calculation or modelization you're going to do with this data is just going to end up into something misleading. Again, The problem is the semantic of the data.
So that's the key kind of conclusion then, is for an analytic system that builds on top of that data, the documentation has to be in place before you can even start a project.
Exactly, and if we go back to bad data, who is to blame? When it comes to semantics, I would say that practitioners, supply chain practitioners, that should be in charge. And here you would say, and most of them would say, but no, it's an IT problem. I would say, but how can you see the semantic of the data really depends on the process that you have. If you have the process where you're scanning products at the entrance of the warehouse because you have this process, etc., etc., the IT department is not, on the ground in the warehouse. They don't know exactly how is your process set up. So actually, the only people who know exactly, because this data is just the result of a process that generates this data in the first place in the system. And so my point is, don't expect IT, who is just managing the machines and making sure that the software has enough computing memory, bandwidth, disk and whatever. So they are dealing with all the computing infrastructure. That those people, I mean, they don't necessarily have the insights and the skills and the understanding that it takes to understand what the data mean, because what the data mean is typically a very business specific problem. It's not an IT problem at all. So so typically here, that's where the blame also frequently lies on, I would say, the practitioner side, is that practitioners have not spent enough time to properly qualify this data with their own words, with their own understanding, and thus when there is this supply chain optimization, you end up with a vendor that end up doing, treating this data and I would say half blind, and thus end up with garbage in, garbage out. Obviously, the vendor can be at fault as well. Companies like Lokad who are doing supply chain optimization, and typically when the vendor is to blame, it's because the vendor, trying to be salesy usually, is trying to minimize, the challenge, because you're trying to sell a problem and you're discussing with, let's say, supply chain director and say, well, trust us, it's going to be a piece of cake. We are going to do that in a matter of weeks, and boom, we are going to do it like that, and it's just going to work. And the reality is that if you tell a supply chain director is, well, I'm afraid that just to qualify your data is going to take 6 months, and sorry, you should have done it, but you did not. So we will have to do it for you. Obviously, it's hard to close this sort of deal. So it's much easier to be like overly optimistic, but then that's a recipe for failure, and then the vendor has to take the blame, because they should know better. Maybe the client doesn't know better because that's the first time they are trying to do like I would say a predictive, quantitative supply chain optimization project, but then the vendor, who by definition it's probably not their first time they're doing that, they should know better. And thus, if they diagnose a situation where this sort of data is inexistent, then they should basically warn the client that they are up to maybe multiple months of effort just to clarify the semantic of the data, so that they have this, so that the data can be qualified as good. But it wasn't that it was really bad at the first. So good is not the opposite of bad in this situation. It's just that good is more like the opposite of dark data or unqualified data or messy data.
Okay, and so to sort of conclude today, it's there's a wide range of different problems that actually come under that umbrella of bad data.
Yes, and I would say try to make sure to identify the root cause of the problem, and usually it's people. I mean, obviously, when I say it's people, you don't want to blame, James from the IT department being responsible for the mess. But when I say the problem is that you need to understand exactly who has the ownership of the failure, and maybe this person was actually put in a situation where they could not do anything but fail. So you see, you can have the conclusion that James from the IT department has failed, but also that the organization itself has put this poor James in a position where he had no other option but to fail, realistically speaking. So, and that's interesting because you start to see, I would say, the problem from an angle that at least gives you clues on how you're going to fix it, as opposed to say, the data was bad, too bad, bad data, and then if you were to do another initiative, you would just repeat the very same problem, the very same errors, and thus end up with the same failure at the end of the day.
Okay, well, if James's boss is watching, let's hope he's being sympathetic anyway. Okay, that's everything for this week. Thanks very much for tuning in, and we'll see you again next time. Bye for now.